start. Good morning, everyone, again. Thanks for joining to this lecture. In this lecture, we will go over several topics related to survey research, actually. In the last lecture, we talked about like how you translate the conceptual model into measurements, and then for instance, how you also ask certain questions, question formulations for respondents to answer your questions in an accurate way to avoid certain kinds of errors. That we also started to talk about errors. We will talk about more today. Building on that, like now you have your questions, but I'm sure many of you have taken some type of survey. There are always, for instance, options for you to click, right? Like you choose from 1 to 10, etc. In some cases, you just type your answer. We will look at the scaling techniques today first. Then we will move on to multi-item scales. Once you have your answers, you need to establish the accuracy of your measurements. So for that, we will look at validity, reliability, and lastly, we will close with factor analysis. One important note is that for factor analysis, do not forget to join this week's tutorial because it is where you will really understand the factor analysis. So beyond the assignment of this week, please don't forget to go to the tutorial for factor analysis this week. And one last thing is I've changed the slide slightly. So I've changed, I added a little bit interim slides to introduce the concepts a bit more. You can already go to Canvas and re-download if you are taking notes on the slides. Good. So let's start with the scaling techniques. As I told, like you have your conceptual model, you then start to create your questions. There are certain ways that you can let your respondents answer your questions. An overview of scaling techniques is here. So we have comparative scales, non-comparative scales, and under that we have different types of scaling. And yeah, as I said, these are then classified into comparative and non-comparative scales. The comparative scales are scaling techniques in which there is a direct comparison of stimulus objects with each other. For instance, you might ask respondents whether they prefer Coke or Pepsi, so you provide two objects for them to compare. In non-comparative scales, each object or each question is scaled independently of the others in a set of questions. For instance, you might ask respondents to rate Coke on a scale from 1 to 10, where 1 means horrible and 10 means very nice. So, and then maybe next question, you ask to rate Pepsi on the same scale, and this would be independently from Coke, right? So this is kind of the intuition behind the comparative versus non-comparative scales. But let's first focus on the comparative scales. We will go over them one by one. The first one is paired comparison. In paired comparison scaling, a respondent is presented with two objects at the same time and asked to select one object in the pair according to some criterion. It is useful when the number of brands is limited because it requires direct comparison of brands. So for instance, here you have these car models basically and from different manufacturers. You ask exhaustively which one of the two the respondents prefer. And this is, again, as I said, it's an exhaustive list. Or you can ask it in this kind of a different scale, like how much more they prefer it between Volvo and BMW, etc., etc. As I said, this works no, as I said, it works well when you have a low number of brands or low number of objects that you want to compare, because when the number of options increase, you have to ask all of them separately, which makes a very long survey. So the pair comparison works well when actually consumers naturally have a limited choice and the test is mimicking how they would normally choose. But the disadvantage is that when there are a large number of brands to be evaluated, the comparison becomes very cumbersome for also the respondents. Next, we have rank order scaling. So this is, again, a comparative scale, but this time you basically provide all of the objects and ask respondents, for instance, to really rank the, in this case, rank based on the importance of these factors like price, comfort, ease of use, etc. And for instance, if the comfort is the most important thing for you, then you put a 1 here. And being stylish, for instance, could be the least important for you. And in some cases, you also, you just have this, please rank the following chocolate brands from least preferred to most preferred, with 1 being the least preferred. So you again make give your ranking for the chocolate brands in this case. The advantage is that, of course, there are now fewer decisions required, so you are not comparing pairs, and it's also represents the natural shopping environment where in your mind you see all the objects and you kind of rank them. But the disadvantage is that in that case, of course, you measure only relative preferences and not absolute preferences, meaning that, for instance, in this case, the comfort is the most important within this set of dimensions. So maybe you have something more important than comfort, but it's not listed here and we don't know that. Okay. And I hope you already see that, this is in the ordinal scale, right? Because indeed you just rank the options. And last comparative scale is the constant sum scaling. In this case, responses are required to allocate a constant sum of units, such as points, euros, dollars, among a set of stimulus objects. And for instance, in this case, respondents are requested to allocate 100 among the types of support according to importance. And this gives you a more granular information into the rank of these different types of support, but also the level of importance in a way. So in this case, for instance, online documentation is apparently the most important for this respondent, but we also see that although telephone support is the second highest, it is quite close to the first one. In the previous the rank order scaling, we were not able to observe that, for instance. So this is, for instance, a way you can have more granular information related to the orders of the choices. And you can also ask this as, you can also provide this sliding option for respondents rather than making them write, because sometimes it's when responses are typing, they might make mistakes. So the advantage of having the constant sum scaling is that, again, as I said, you have finer discrimination among objects, and in many cases you can treat this as metric data. So you have the ordinal nature, but on top of that, you can really understand if they're close to each other or not. And there is, of course, as you can see, you can also put 0 here, right? So there is an in the cases, in some cases, there could be also an absolute 0. For instance, if you are distributing euros among this. The disadvantage is that, of course, the respondents need more cognitive effort because you really need to think about like where I'm ranking this, but how much more important, for instance, telephone support to me than online chat support in a very granular way. So with this, the summary of comparative scales, you can see here advantages and disadvantages. You can read this on your own. I will just say that the major disadvantage of the comparative scaling is generally the ordinal nature of the data and the inability to generalize beyond the objects, like the stimulus objects that are provided in the scales. So you always have some list of stuff, list of objects that you ask to your respondents, and it is very hard to go beyond that. So for instance, to compare the Albert Heijn, the house brands, Cola versus Coke and Pepsi, and that if you want to understand the differences between these three, the previous questions of Coke versus Pepsi would not help you because you didn't include in your set the Albert Heijn brands. So you need to do the survey all over again. This kind of advantages can actually be overcome by using a non-comparative scaling technique. Because in non-comparative scales, as I said, each object is scaled independently of the others. And the resulting data are generally assumed to be interval and ratio scales. So we can also overcome this ordinal nature of the data. And this will become very important because in our further analysis, like hypothesis testing, regression, etc., you need to at least have an interval level of the measurement. So let's now look at the non-comparative scales. And as I said, the non-comparative scales, in this case, you rate each object separately and independently. And these are split into continuous rating scales and itemized rating scales. In continuous rating scale, it is more free, we will see. And in the itemized rating scales, you really want the respondents to just select one of the options that you give them. You really restrict the set of options. Let's start with the continuous rating scale. A response using a non-comparative scale employ whatever rating standard seems appropriate to them in this case. So they, as I said, they don't compare one object to another, but only evaluate one object at a time. And in the case of continuous rating scale, the respondents just place a mark at the appropriate position on a line. So in this case, the question is, to what extent do you involve your children in family decision-making? Not at all to extremely involved. And you can, as a respondent, you think that, yeah, it's about here. You are provided with the extremes, but this provides a continuum of values. The advantage of that is that the researcher can really divide the line into as many categories as desired. So it's free from the researcher's perspective. It's also good that you are getting this granular information here, rather than only giving options 1, 2, 3, 4, 5. You can also think about having this not at all and extremely involved, for instance, and then they can also put a mark here. The disadvantage, though, is that once you have the scores, like this marks, you really need to score them. And it's a bit hard to score exactly, like it's very hard to understand where they wanted to put the score. To overcome that, you can use itemized rating scales. These are still non-comparative scales. In such scales, the responses are provided with a scale that has a number or brief description associated with each category. And the categories are ordered in terms of scale position. And the respondents are required to select the specified category that best describes the object being rated. So the most commonly used itemized rating scales are the Likert scale. For instance, in this case, the question asks, the statement says the customer service representative was knowledgeable. So this is a statement. In a Likert scale, you give a statement and you ask the respondents if they agree or disagree with this and how much they agree and disagree with this statement. In this case, we have a five item scale. So you can choose from strongly disagree to strongly agree. In the Likert scale, this is really just very it is an itemized scale, right? Like you cannot choose any other option, but it is very important to observe that in a Likert scale, you will always have a scale of agreement. So this would always go from disagreement to agreement, or you can reverse it to agreement to disagreement, but it's always about agree, disagree. You will understand this in the next scale. What could be the difference between, for instance, semantic differential scale? The advantage with this is that it is easy to construct and administer because the response will easily understand this, right? There's a statement and you just say you agree or disagree. The disadvantage is that if you remember, we talked about this reverse questions, right? When you ask reverse questions, it might be very hard to understand what the meaning of agreement is. So for instance, if this question is the customer service representative was not knowledgeable, it is hard to understand what the meaning of strongly disagree is because it's kind of double negation. So that's kind of the disadvantage with the Likert scale. And with the semantic differential scale, this is again similar to Likert scale in the sense that you have, I don't know, 5, 7, 9, generally odd numbers of categories that are available to be chosen by the respondents. But now you actually, at the extremes, you provide bipolar labels. So in this case, you provide, for instance, this, I don't have the question here, but if you want to, if we want response to rate the cleanliness, this can be related to a product, for instance, I guess. Clean versus dirty, dark versus well-lit, low quality versus high quality, innovative versus conservative, convenient versus inconvenient. In the second one, please tell us whether our stuff made you feel valued, unvalued. So you got the gist, I guess. So you always provide this bipolar labels, and then the respondents will choose between them. So this is not agree, disagree, as in the Likert scale. So that's how you can actually distinguish the two. Okay, I think, okay, we said the continuous Likert and semantic differential. Now let's look at an example. I already revealed the answer, but in this case, I want you to answer in Q&A what do you think the measurement levels are with these questions. So for instance, let me first answer this one because I already revealed. For instance, when you ask the respondents, how old are you? They will just enter a number here, right? So you can see that this number has an absolute zero, it has equal intervals, and we can order this. So this is a ratio level. If you remember from last week, we had nominal, ordinal, interval, and ratio measurement levels. So the second question here, please tell me which is the measurement level. Please rank the following activities in terms of your preference by assigning numbers. 1 is most preferred to 5 least preferred. So I see an interval answer. Any other answers? Ordinal? Yeah. So Samael, I see that you say rank order scaling. I think that can indeed be a confusion because we use scale in different cases as well. When we mean the scaling, it is related to how we are asking the respondents, like which options we are giving to the respondents. And when we talk about measurement level, it is related to these 4 levels of measurement, which are hierarchical in themselves. But there is, in general, one-to-one relationship between the scaling and the measurement level. So this indeed is a rank order scaling. We do it from 1 to 5. But as I mentioned, this is indeed ordinal. Why is it ordinal? We will, yeah, I mean, the response will answer this, let's say 1, 2, 3, 4, 5. So this gives a ranking, so we can order this, but we don't know if there are equal intervals. Remember, if in the interval measurement level, we talk about an equal intervals between the numbers, but can you really say, like, if this is 1 and this is 2, the difference between that is equal to difference between these two? It doesn't have a meaning in terms of the difference of the numbers. So in this case, this is ordinal. So now let me ask you, what is the measurement level here? What is your social security number? So this is a bit hard. This is a hard question to ask in a survey, but let's say this is the case. Any, yeah, I see nominal. Yeah, indeed, it might be even illegal to ask this, but just for the sake of example, yeah, I see nominal as answers. Any other opinions? Okay, so indeed, this is a nominal variable. Even if this is a number, this number only labels the respondents based on their social security number. This particular number doesn't have absolute zero, or it doesn't have equal intervals. This is a very long number in general, right? So the number itself doesn't have a meaning. It could have been just characters as well. The fourth one is, on an average weekday, how much time do you spend doing your homework and class assignments? Less than 30 minutes, 31 to 60 minutes, 60 to 120, etc., etc. So what do you think the measurement level here is? Yeah, interval, ordinal, interval. Yeah, this one is a bit more tricky. So I get the answers of interval and ordinal. So it's nice in the sense like, indeed, this is not nominal or ratio, but here it's, I mean, I understand why you're thinking interval, but it is not clear if the, like once the respondents choose one of these options, the distance between these two, so for instance, you have a 30-minute bracket here, you have a 60-minute bracket here, and you have 120-minute bracket here. And then this is more than 240 minutes versus less than 30 minutes. So once you go from this answer to this answer, it's the interval, like the leap that you're doing, that you're showing, is not the same as when you choose this answer, right? So in that case, it is very hard to actually say that these are equidistant options. So that's why we can call this an ordinal measurement level. If these were really every like 30-minute, 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 then we could have justified maybe an interval measurement. But in this case, this is ordinal. And I hope that's clear. If it's not, please ask follow-up questions. Lastly, how much money did you spend last month on entertainment? Yeah, I see one ratio. Yeah. So indeed, this is on ratio level or ratio scale, because this is simply euro amount that you will enter here. We have an absolute zero. When we subtract consecutive numbers, the distance is the same. We can order these, and each of the numbers also signify a value. So it has a label. So it has all the characteristics of a measurement. Yeah, I don't see a raised hand, unfortunately. No. Okay, now I see. Okay, Laya, please.
Yeah, I just wanted to clarify number 4. So even if we see a pattern that it's multiplying by 2 for each section, for example, from 30 to 60 is 30 times 2, 60 to 120 is times 2, 120 to 240 is times 2. Even if we see that pattern, unless it's exactly the same amount of distance between, then it would not be integral. Is that correct?
Yes, that's correct.
Okay, thank you.
Yeah, good. Any other? Yeah, I don't see any other hands. Let me also make a comment here. Wait, we have one more, sorry. So the last one is, I like to solve crossword puzzles from this agree to agree. And this says, please circle your answer. Yeah, ordinal, interval. I see one nominal. Okay, so in this case, I should have been a bit more clearer in terms of what these options are. So this part is critical, that in a Likert scale or in a semantic differential scale, when you have options, as in this question. I mean, this is not, none of the two, but when you have Likert or semantic differential, you should think about if you can justify if this distance between 1 and 2 is the same as 2 and 3, etc. If this is disagree, like completely disagree, neutral, agree, completely agree, then it is easier to justify this equal distances because we also know that 3 is a neutral statement. In both Likert and semantic differential, if you have this neutrality in between, that's also why it is very common to use odd numbers of options here. Then we can claim this as an interval measurement level. Okay, and you generally start with 5, like 5, 7, 9, 11. You can get more and more granular. I hope that makes sense, that if the middle, like you have odd numbers of options and the middle option represents neutrality, and you can see that 2 and 4, for instance, is that, let's say, in this case, disagree. So 1 is completely disagree, 2 is disagree, 3 is neutral, 4 is agree, 5 is completely agree. Then we can say that, okay, these the difference between the numbers are actually equidistant. We still don't have a absolute zero in this case. We don't have a zero, actually. So we can say that this is interval. But if we cannot justify the equal distances, so for instance, if this goes from, I don't know, completely disagree, then you start to actually agree options, agree, slightly agree, completely agree, something like that. Then we cannot really talk about equal distances. So once you have a question, please check if you have a neutral statement, if you have an odd number of options, if you have a neutral statement in between, and if the options on the symmetric side actually correspond to each other, so that you can justify these equidistances. Yes, it is indeed because we don't. I mean, in this case, the ordinal answer is not necessarily wrong because it is not clear here. So if I said 3 is neutral, and if I give all the options, then you would be able to say if it's ordinal or interval. In this case, both answers would be correct. Good. And then you can check the one-to-one correspondence to the scales, comparative scales, and their measurement levels. Same goes for the non-comparative scales and measurement levels. Here, as I said, there is a note related to Likert and semantic differential if you don't have a neutral statement and odd number of options in general. But it's like in practice, it is common that people would just treat this as interval and put in hypothesis testing and regression. Let me see. No, we will just cover one lecture. Yes, I can do this. So let's go back to, it's an important part. So for instance, here, we had strongly disagree, neither agree nor disagree, which is a neutral option, agree, strongly agree. And then if, let's say, 3 was, let's say 3 is agree and 4 is 3 is slightly agree, 4 is agree. Then it's very hard to say that disagree to slightly agree is the same distance as slightly agree to agree. So that's why if you want to treat this as Likert, you want to have this neutral, the neutral statement in the middle, And then you want this scale to be symmetric on each side. So disagree, agree, strongly disagree, strongly agree. Then you can talk about these equal distances between these numbers. And I hope that's clear now. What if there is no neutrality? Is it then ordinal? Indeed. Then it would be ordinal. Good. Okay, yes. So the itemized rating scale decisions then, as we said, this is a non-comparative Likert or Likert and semantic differential. How do we construct this? As I mentioned, optimal number of categories is between 5 to 9, and then you generally choose an odd number to have that neutrality. Data most objective with a balance scale. As I said, the symmetric options is important. The odd number of categories, indeed, like in some cases, you want to give the option of this not applicable to the respondents as well. That's only when you add this option. But in many cases, you tend to force actually response to put an show an opinion related to the statements. And then finally, the like category descriptions should be as close as possible to the response categories. So whatever you want to measure here, it should be reflected in the category options. Yeah, so for instance, yeah, this is a good example. So I was trying to come up with the example, but you can see here that this is more balanced, like very poor, poor, average, good, excellent. It's more balanced. Versus example 2, here we have poor, average, good, very good, excellent. So neutrality is in the second one. The poor to neutral is probably a bigger distance than average to good, for instance, and good to very good, etc. In this case, you would treat this, you should treat this as ordinal in general. Yes, and then you can try several formats before actually using it. You can pretest this scales with your respondents. Okay, let's move on to multi-item scales. So you had you had your questions. You then chose on some kind of scale items. You also decided to use, I don't know, 5, 9 option scales. In some cases, you use what's called a multi-item scale. And then, of course, there is kind of an antagonist of this, which is the single item scale then. So let's now look at what these are. So if you remember this Ahold Delhaize example, we had this managerial support causing employee motivation, and then that causing in turn the employee productivity. Then this was the mediator. We also wanted to understand how age actually moderates the relationship between the two, or how managerial supports affects employee productivity, how age moderates this relationship. And for instance, we can simply ask respondents to please enter their ages, right? In this case, it is called a single item scale. We have one question to measure one concept. In this case, concept being the age. Of course, this is quite simple, right? Is there? Yeah, I'm looking at the question. If there is a non-applicable option, does it imbalance the symmetry? Yes, indeed. This is an indication that, like, if you don't have a neutral statement, it's very hard to argue that the leap between good to, like, bad to good or good to bad is the same as the levels of badness or goodness. So we said that in the case of age, the concept is simple, so you can directly ask this. In some other cases, though, the concept you're after is not that simple. You do not or cannot observe the concept directly because it's complex or abstract. So in this case, for instance, if we think about the managerial support, it's more vague and abstract than the age. So we can come up with this kind of a scale where we ask multiple questions to actually evaluate the concept of managerial support. So my manager considers my feeling, my well-being is a priority for my manager defends me from unfair criticism. And the rating scale here is Likert, strongly disagree to strongly agree, and it's balanced, right? In this case, you want to, as I said, you want to understand this concept by asking multiple questions, or we call this also items. So question and item is the same thing. And we will also, and because we ask multiple questions to understand this concept, we call this a multi-item scale. So this is a multi-item scale to measure this concept. And the concept we also call a construct or a factor as well. So this is the construct or factor we are after, the managerial support. We want to understand this. Then we have attached to this item 1, item 2, and item 3. Notice that we don't observe, so we don't really directly observe this managerial support, but we observe this item 1, 2, and 3, which corresponds to this 1, 2, and 3 as the questions. So this is what a multi-item scale is. Yeah, I think I can come back to this, but I don't want to go into moderation and mediation at this point. So I will leave this to the end. So as I said, these items are also questions, and we can have single item measures versus multi-item measures. And single item measures are close to the, like when you want to actually measure simple constructs, factors or concepts, they all mean the same thing. In the case of age, gender, and brand liking, these are simple concepts, and then you can simply ask their age, gender, like response age, gender, or how much they like a certain brand. In the case of multi-item measures, when you look at these concepts, for instance, subjective well-being, if I ask you how you are feeling today, or like if I want to measure your subjective well-being, it is very hard to measure this with a single question. So I should probably ask more detailed questions related to each other to kind of construct and understand better this concept underlying the subjective well-being. Innovativeness is again very similar. It's very hard to ask, like, are you innovative? Like, people would understand very different things from this question. So you really need to understand the dimensions of innovativeness, for instance. And employee satisfaction could also be where you ask multiple questions, different aspects of satisfaction to construct a more accurate observation of this concept. And though when you have these complex variables, of course, it's very hard to measure them with one item. You also need to be careful about the question wording, measurement scale, and definition of the construct. As I said, these dimensions, you probably, not probably, but you basically learn them from the theory, like what are the dimensions of innovativeness that you should pay attention to, and then you basically go and ask that important questions. So we said we have single or multi items. should we choose single or multi-item? A single item measure is appropriate if the object being rated is simple and unambiguous, as I said. So this can be an advertisement or a brand. The attribute on which the object is being rated is also simple and unambiguous to the raters. So your question should also be simple enough to understand for the respondents so that they can really give an accurate answer. And then a multi-item, the advantage with the single item then is it's a simple construct. And then if you want to add questions related to this, you might actually make it more less clear for the respondents. So once the concept is actually simple, just go ahead and ask one question and be very to the point. Because if you ask multiple questions, then these other questions might be related to other kinds of concepts, and then you don't get this clean measure of what you're after. And a multi-item measure, as we said, we have one construct, one underlying construct, which we don't observe. But it's too abstract to capture by a single item. So this is when we have concepts that are abstract or complex, we need multiple items to measure them. And here what we are after is their validity and reliability, which we will also go in this lecture. The advantage with the multi-item scale is that we can calculate Cronbach's alpha, which is a reliability measure. We will also see this. And the multiple questions give you more opportunities to actually differentiate between the people or respondents scoring high versus low, because you have more granular understanding. But again, the trade-off here is that if you have simple concept versus a complex concept. And within wouldn't the multi-item measures be qualitative? I'm not sure what you mean by, I mean, this can be a quantitative measurement as well. You basically ask, for instance, in the case of managerial support, we had the Likert scale from 1 to 5, and those are quantitative. So you will get numbers and you can process them as quantitative data. So this is not about being qualitative or quantitative. Yeah, is the Likert scale is shown is not interval? If you're talking about the managerial support, it was indeed interval because we had the neutrality and balanced scale. So there are two types of multi-item scales. One is the reflective scale. So if all items are the manifestations of the same construct, so you ask you basically ask the same question in different ways, and the items are close in meaning to each other. If this is if it's this way, you would expect that the people with the underlying construct will answer the same way. So people with high level of the construct behind it would, for instance, answer agree in the case of a Likert scale. And if you have a formative scale, the items measure different dimensions of the construct, in which one dimension can be measured with more than one item as well. So in this case, the items are actually quite different, and it looks at the characteristics or the dimensions of the underlying constructs. You can also think is it kind of additive, that these items would add up to the construct. So to distinguish reflective versus formative, you can also ask, does it actually contribute to the construct, or is it a manifestation of the construct? And in the case of manifestation, you go with the reflective scale. And in the other case, if it's contributing, then you can talk about a formative scale. But in both of the situations, it's important to use the same scale of measurement. So you still use, for instance, Likert scale for all of the items. So these cannot really differ. So in a multi-item scale, each question should have the same type of scale. I hope that's clear. Yeah, the manifestation is basically like if your subjective well-being is high, then you would answer the question of like, how are you feeling today? Probably by agreeing, or like, I feel good today should be an agree for you. So your subjective, so your answer is reflected on your subjective well-being, rather than if we talk about innovativeness, for instance, we can talk about several aspects of this. We can talk about if you like to try new things, or you are easily bored with things, like, or you actually what else could be? You want to do things in different ways. So yeah, innovativeness scale can actually have different, or in this case, I will in a moment ask socioeconomic status. Yeah, actually, I won't. Yeah, let me ask other questions. I have other questions. The socioeconomic status is related to many things, right? It's not, we cannot simply ask someone, what's your socioeconomic status? This is about your background. This is about your income. This is about your like social circles. So in that sense, this, you can think it as different characteristics adding up to the socioeconomic status. So in this case, for instance, the formative scale. Yes, we will exactly go there. So if we want to, for instance, measure life satisfaction, so the underlying concept is life satisfaction. We have the scale. I'm satisfied with my life. So far, I've gotten the important things I want in my life. In most ways, my life is close to ideal. The conditions of my life are excellent. If I could live my life over, I would change almost nothing. So in this case, you can see that this life satisfaction scale, the items in this are actually close, very close to each other. It's almost asking the same thing in different ways. So in this case, this is a reflective measure. But if we talk about, for instance, perceived service quality, this can be related to many different characteristics. So you also have the questions here, which I know it's a bit hard to read, but overall, for instance, this quality, service quality can be related to tangibles quality, reliability, responsiveness, assurance, and empathy quality. And as you can see, these are not necessarily asking the, like, measuring the same thing in different ways, but these are actually the characteristics or the dimensions of perceived service quality. So in this case, these items are actually forming the perceived service quality. And under each one, there are multiple questions. I hope it's a bit more clear now. The reflective could also have more questions. Yes, the number of questions, number of items is not how we determine if something is reflective or formative. So in this case, this is formative. Let me show you two examples and ask you if you think this is reflective or formative. So these are actually quite close concepts. One is related to diet and the other one is related to health. Let's start with the first one. So let me actually get this out of the picture. When we want to measure diet, we ask I eat healthy, we give statements, and we ask basically, do you agree or disagree with this statement? Or how much do you agree with this statement? I eat healthy food. I do not eat much junk food, and I have a balanced diet. So what do you think is it a formative or a reflective scale? Yeah, reflective. Yes, I get the reflective answers, and it is indeed this one is indeed reflective, because this is basically this asking the same question in different ways, and then we have this underlying construct of diet representing if you have a good diet or a healthy diet, then the manifestation of that would be you would agree with all of these statements, which are very close to each other. So that's also why, because it's a manifestation, you can see in this conceptual representation that the arrow is going from the diet to the item. So the arrow is from the underlying construct to the item. And in the case of health, here I have a balanced diet, I exercise regularly, I get sufficient sleep each night. So what do you think this one is? Yeah. So I see formative as answers. I think I also gave it away a bit, but this is indeed formative, and I hope you are seeing it more clearly with this example that in this case, we ask questions related to their diet, their exercise, and their sleep. And these are kind of dimensions of health that are in a way additive. And these can also potentially compensate for each other in the formation of health. Yeah, I mean, to a certain extent, but we would always expect these three answers to be very much correlated, right? Like they should, the respondents should actually agree if they are doing, if they say, I eat healthy food, I do not eat much junk food, the agreement between these questions should be quite high. In this case, we also indeed expect like good correlation for very much healthy people, but this is not as clear as this, because this is manifestation of the underlying construct, whereas this actually forms the construct. So in this case, the arrows goes from the item to the construct. That's also a way, if you are provided the conceptual model, to identify formative versus reflective. The E1, E2, E3, we are exactly going there. So you will see in a moment. Those represent the error though. So let's check. So let's now look at validity. Here we will have the starting example. We want to understand willingness to pay for environment in this conceptual model. We have a single construct, but we will add more construct as we go. Would give part of my income to the environment, increase in taxes if used to prevent environmental pollution. So you would agree to increase taxes if it's meant preventing environmental pollution, and government should reduce the environmental pollution. So in this case, we represent, and this you answer is strongly disagree to strongly agree. Willingness to pay, B1, B2, B2, B3. So these are the items to measure willingness to pay. So we ask these questions and we gather the answers. How do we expect these items to be correlated if we, like after we get our answers? Yes, we will get a break soon. Let me cover the errors and then we will take a break. So do you expect these items to be highly correlated, or maybe the correlation should not be high? Any answers? Yes, so indeed, in this case, we would expect a high correlation because we ask, like if you look at carefully the questions, a person who would agree with this should also agree with increasing the taxes for better, like to prevent pollution. And they should also agree that government should reduce environmental pollution. So these should, the consistency between these answers should be quite high. And this is also how we will analyze the questions later on. Can I explain the correlation a bit more? So it is really about if we have a respondent and this respondent said they agree with the statement that they would give part of their income for the environment, they would also say that, okay, I can pay more taxes if it means preventing the environmental pollution. So this means that we would expect a high number observed here. So if they say strongly agree, would probably say we would probably choose strongly agree here as well. So that was what's meant with high correlation. In this case, this example would be reflective. Yes, Alexandra, indeed, in this example, the questions are quite similar to each other. So it is reflective. If they answer the same, yes, that is true. If like someone else could be very much opposed to this, sorry, these questions, if they say, okay, I don't want to give any of my income to prevent, like to protect the environment, then they would be very much likely to say strongly disagree to this as well. And that would also be a high correlation. That's a good one. Okay, so we will not finish early, but let me give you a break at this point. And I see what time is it? So let's meet in 10 past 10, please. And then we can continue. So I will see you at 10 past 10. Measurement error. So you prepared your survey, you collected data, and you now really want to understand if your measurement was accurate, right? So we can always ask questions to people and they will just give some answers, which also represents some numbers. But we really want to understand if we measure what we wanted to measure. And this means that our measurements should be clean from some type of measurement errors. And when you do research, you care a lot about the accuracy of your measurement, but the measurement is not the true value, and it's just an observation. But what I mean by this is if, for instance, I ask you about how satisfied are you with your life in general and give you options from agree to disagree, you will give an answer, but is this really the true value of how you are satisfied with your life in general? It's possible that you might be distracted while you're answering this question. You might have a bad mood while answering this, or you really you base your answer on today or how you felt this morning rather than a general reflection of your satisfaction. Hence, in this case, what is really in you as an answer, your true reflection of the life satisfaction, might not be reflected in your answer. And that then is a discrepancy between what we observe, what we measure, and then what the true value is. And if there is a difference between this true value and our observation, we call this a measurement error. And in this case, you see that we have this observation. This is the true value of what we are after. I want to understand your life satisfaction in general, and this is the measurement error. And as you can see, it has two components. One is the systematic error, and the other is the random error. For instance, in this case, a systematic error, for instance, in this case, a random error would be that while you're answering, someone walked past you, and then you got distracted and you gave a different answer. So we can also take, for instance, the example of exam questions. So when I prepare exams, I want to understand how well you understood the topics, right? And then this is what I want to measure. But there might be cases, for instance, when you are 10th and taking the exam, as someone just walks past and you get distracted, and you just, even though you really have a good understanding of the material, at that point you were not able to give the correct answer. So this, for instance, would be a random error. But there might be a case that while preparing the questions, there was a bad formulation with the question, and everyone actually understood something different from that question and answered in a particular way. And in this case, there is a systematic problem, and this would be a systematic error. And I wouldn't be able to measure what I'm really after. So there would be a difference between the true value and what I observe. So let's so this is a conceptual representation of what I just said. The true score is, for instance, in our example, is related to willingness to pay. And we measure it with 3 items, which are related to you want to pay, and do you want to, let's go back actually. Maybe that's better. Would give part of my income for the environment, increase in taxes if it will be used to prevent environmental pollution, and that the government should actually reduce environmental pollution. We measure willingness to pay with these 3 items, and each item can actually come with its own error. So this is what E meant in the previous question as well. And these can be, for instance, related to random errors. So for instance, you answer online, you were not able to concentrate enough. So then, then your answers actually don't reflect the reality about you. Then that would be an error. There could be also something way more systematic. For instance, we want to understand your perception of a particular advertisement. We depict a picture, and then this picture depicted is about a person who did something very bad, and then everyone, a bigger population, like bigger number of respondents, actually answer in a very particular way to the questions, and then this would, for instance, induce a systematic error to the answers. So how do we actually evaluate? So we said, okay, we are after this true value, but we can make measurement errors. How do we evaluate this? So we evaluate this in terms of reliability, validity, and generalizability. We will look at the reliability and validity. Under validity, we will look at now the construct validity. And for the last two, I have summary slides at the end, and I just want you to read them and make yourself familiar with them conceptually. In general, what is validity? Validity is about the extent to which differences in observed scores reflect true differences among objects on the characteristics being measured, rather than systematic or random error. So what I measure, does that really reflect what I wanted to measure? So the true value versus what I observe. If my measurement is valid, then I should be able to really distinguish the high scores from the low scores, like the people who really want to willing to pay for the environment versus people who are not. And yeah, in terms of errors, then this implies little systematic or random error. If you look at this bullseye representation of data, for instance, our target is the middle of it. So this is a true value basically, and we take measurements related to this. In this case, we get like a good cluster of answers, so it is quite consistent. But so that consistency will be about reliability. We will see it in a minute. But this is invalid because we are not actually measuring what we want to measure, but we are measuring it, like our observations are actually quite consistent. They act like they are in a cluster. So this indicates, for instance, a systematic error. In the case of a random error, we actually have this dispersion. This is not very accurate because we are not measuring the true value, but at the same time, the answers that we collect are also very inconsistent. This would, for instance, signify a random error. And for the validity, we both want answers around the true value, close to the true value, and it should not be systematic. So now let's actually add another construct, because we will look at in the validity, in the construct validity, we will look at convergent and discriminant validity in a moment. We looked at this willingness to pay, but we also have a second construct with 3 items, which is related to environmental problems in the world as a whole. Please tell me how serious you consider each of the following to be for the world as a whole, from very serious to not serious at all. Global warming or the greenhouse effects, loss of plant or animal species for or biodiversity, pollution of rivers, lakes, and oceans. Yeah, for instance, in this case, it says a formative scale, as you can see, just as a side note. But what we are really interested here is that if both of these both of these constructs are valid, then their items should be very much correlated within themselves, as we just talked. Like we expect high correlation between the items that belong to the same construct. So this we will call a convergent validity soon. But at the same time, we are measuring multiple constructs, right? So we also want certain items. So for instance, this item to be not very highly correlated with the items here, because otherwise there is an ambiguity about if this item is related to this construct of environmental problems in the world, or is it about the willingness to pay? Do we intend to measure what we want to measure? So we will actually look at that with convergent and discriminant validity. And a side note here is that we have as you can see, from very serious to not serious at all. And here, strongly agree to strongly, strongly disagree to strongly agree. So increasing numbers here represent agreement, like more environmental sentiments. And here it actually represents less environmental sentiments if someone answers this 5, for instance. So that's why we reverse code these scores to make them increase with the increasing seriousness or increasing environmentalist sentiments. And we will use, to establish validity, we will use the correlation matrices. So each of these, like what you, the metrics you see here, the items are here, and then you can see the correlations between all items in this picture, basically. So for the first item, the second item, we see the correlation between the first item and the second item, for instance. And this 0.243 is the correlation between item 1 and 3. Same goes for here. Okay, I don't see any questions. Let me go to, okay, good. So as I said, we have two constructs. We want to, for this construct to be valid, we want convergent and discriminant validity. And convergent validity is about, do the items designed to measure the same construct correlate highly? So within these groups of items, we want high correlation. That's the indication of convergent validity. And for the discriminant validity, does the measure have a low correlation with a variable that is supposed to be unrelated to this variable? And if it's intended to measure another construct, then we expect a low correlation between these items and these items. So for the items under the same construct, we want a high correlation and agreement. And for the items of different constructs, we want low correlation or this agreement or discriminant validity. Okay. And let's now look at a bigger correlation matrix, including all of the items for the both of the constructs. So 1, 2, 3, 21, 22, 23, and these are reverse coded. Here, to establish convergent validity, we should look at the items under the same constructs. So let me highlight those here. So in this case, we want these correlations to be high and these correlations to be also high. The 1, 2, 3, the correlation within each other would establish the convergent validity of willingness to pay. And then these 3 correlations will establish the convergent validity of the environmental concern. And in this case, you can see, by the way, we will always, like what's high correlation, what is low correlation. We don't provide here a rule of thumb. Whenever we want you to evaluate a high versus low correlation, we will always provide you with the thresholds of high versus low correlation, okay? But in this case, let's say our thresholds is 0.6 and above is high correlation, and then between 0.2 and 6 is moderate, and below 0.2 is low. With that threshold, for instance, you see that the item 2 is very much like highly correlated with 1, but item 3 is actually not highly correlated with 1 or 2. So this might be concerning for the convergent validity of this willingness to pay construct. For the environmental concern, what we see here is that these are 0.5, so these are moderate, it's almost high. Here again, this is moderate, so convergent validity is okay, we can say. Again, whenever we ask you questions related to this, things would be more clear-cut. But overall, you can see here is the convergent validity looks better than here. Sorry. One other thing is that we can talk about the convergent validity of the factor. So when we talk about the factor, we look at all of the correlations, but we can also look at the convergent validity of an item in a construct. In this case, for instance, we look at the item 3. Then we see that this correlation is actually not very high. And then we can say that the convergent validity for item 3 is low. Any questions at this point? I will have an example related to this soon. So let's also go over once more there. For the discriminant validity, by the way, I'm just shading this part because the correlation matrix is symmetric, like the numbers that you see here are the same as the numbers you see here. For the discriminant validity, as I said before, we want to understand the cross items. So if the item of one construct is related to the others, and we want it to be not related, so we seek low correlations to establish discriminant validity. And in this case, then we look at this cross correlations. So the items of environmental concern to items of willingness to pay. So this is important to understand. Like when we talk about discriminant validity, we want to understand we look at the correlations between the cross constructs, basically different constructs. And here, as you can see, all of the correlations are actually below 0.2. And by below 0.2, I mean the absolute measures. So these correlations are quite low. And we then can establish that the discriminant validity of willingness to pay and environmental concern is actually quite high. So the items of these constructs measure different things. I have one question here. Is the discriminant validity broken by negative correlation? What do you think? Maybe we can quickly go over that. I'm also keeping track of time because, yeah, anyways, I think, skip this question, but skip this question to ask you, but let me answer it. A negative correlation or a positive correlation, it doesn't break anything. Even if you have a negative correlation, this correlation could be high. A negative correlation is more strong if it is closer to -1. And if a correlation is closer to 0, then we talk about a low correlation in general. So in this case, this -0.022 is still a low correlation, but it's not because it's below 0.2, but it is actually between -0.2 to 0 with the thresholds that I just provided. So you can always think about absolute correlations to look if the correlation is high or low. Okay, so in this case, for instance, we have again three different, not again, but in this case, we have three different constructs: knowledge management, quality control, and computer technologies. Each of them are measured by three constructs. So these are the codes for the items. Did I say construct? So the knowledge management is the construct, KM1 to 3 is items. So there are three items for all of them. So let's look at, for instance, the convergent and discriminant validity of the survey item QC2. So this one. So what I will say to you, and please do for the other ones, is that in terms of convergent validity, we have to look at its agreement with the items in the quality control construct. And if we take the, again, 0.6 as a high correlation, then you can see that it's like there's a high correlation with QC3. There is a moderate correlation with QC1. So in this case, we can say that the convergence validity is okay. So because there's one high correlation and there is one moderate correlation. With the discriminant validity, we need to look at its correlation with the other items in other constructs. So here, so this first three looking at KM items, and the last three looking at CT items. And we want these to be low, to construct the to establish the high discriminant validity. So here, as you can see, these are 0.4, 0.4, 0.4. So these are actually moderate correlations, and we want them to be low to establish a discriminant validity. So we can say that the discriminant validity for QC3 as QC2 is actually low. Same story goes for here as well. So when we look at all of these, we see moderate correlations, which means that we have a low discriminant validity. Okay, now reliability. In the reliability, there are different forms of reliability. I have a summary slide at the end about these, so please go and check those. Here we will look at the most important and most common one, that is the internal consistency. Just to compare, validity and reliability, we said that validity is really about whether you can measure the true differences among people. If your questions are, to establish validity, you need to understand the extent to which differences in observed scores actually reflect true differences among objects on the characteristics being measured, rather than systematic or random error, as we said, which means, do you measure what you want to measure? Sorry, there is a construction going on here. If you are hearing noises, sorry for that. So high validity implies then little systematic or random error. In the case of reliability, we talk about the extent to which a scale produces consistent results if repeated measurements are made. Okay, so I ask a certain question multiple times in different ways, and people should answer in the same way. And strictly speaking, I should actually ask the same question over and over again to respondents. But in many cases, of course, this is not possible because people will remember the question and they will answer in a particular way. So what happens in practice is that there are similar questions that you can ask, and then the respondents should answer consistently, as we just seen, for instance, for a reflective measure, then if people are more environmentalist, they would score highly for the willingness to pay for the environment, the items related to that. So the issue here is that it's really, will you get the same result every time? This means, importantly, that when you have high reliability, you have little random error, but the systematic error actually has no impact on reliability, because it influences everyone in a constant way. So let's give you a picture of what I mean here. So we have three, again, bullseye representation. In the first one, the observations are dispersed, and they are not very close to the true value. This is not reliable or valid. Here we see like we don't see a systematic error, but we see a lot of random error. And yeah, as I said, because these answers are not consistent, so they are not clustered, we say that this is not reliable or valid. And reliability, don't forget, is a necessary condition for validity. In the second case, this is a reliable but not valid. So here we, if you remember, this is systematic error. We see clustered answers. So everyone answer in a particular way. So we get consistent results. But then the answer is, the observations are not close to the true value. And if we can measure the true value in a consistent way, so if we have both cluster of observations and it is in the middle, then this is both reliable and valid. And in general, you can see that a reliable and valid measurement has a low error in this case. Good. I don't see any questions related to this. Yeah, please make sure that you really understand these pictures. It's a good way to kind of remember which kind of error is related to reliability or validity. But the error is close to the true, meaning the error is not. So I don't mean the error is close to the. Maybe I said it that way. Sorry if I did that. The observation is close to the true value. And then in this case, error is quite low, right? You just have random error, random dispersion around the true value. But all of the values overall are quite clustered. They're close to the true value. So in this case, we have little systematic or random error. And in this case, the answers are clustered. So they are quite consistent. So it's reliable. But we have a systematic error because the true value was here. So everyone is affected in a certain way. So for instance, the question formulation was very bad, that people understood it, like everyone understood it in a different way, and they gave consistent answers. And in the case of reliability, we are interested in internal consistency reliability. As I said, the reliability is related to association between scores obtained from different administrations of the scale. So you have basically different formulations of the same question in a multi-item scale, right? And then you want these associations between these items to be high. And if this is high, this means high, this shows high association, then it means you have consistent results, and then reliable scale, and then little random error. But it doesn't say anything about the systematic error. And internal consistency reliability means that the items of the same construct are interrelated. So we, in this case, have two types of reliability, split half reliability. So you basically split the items into particular groups and check if these items are correlated. So if you have 4 items, you split them 2-2. And then you look at the reliability within. This is not very common. So we will mainly use in this course coefficient alpha, Cronbach's alpha, or as it's called. So this is a measure of internal consistency reliability, and it's a function of number of test items and the average intercorrelation among the items. So just to give you a picture of what do we mean by internal consistency, if you have multiple items related to a question, for this respondent, the answers are quite consistent, so 6, 6, 5, 7, 6. And in this case, although the questions are very much related to each other, so it should, like a person high in the underlying construct should answer it in a high manner. So we have high internal consistency here. But in the case, for instance, this is the answers here are dispersed in anywhere. So we don't know if this person is high or low even. We can't really distinguish between the items. We cannot distinguish if this person is high in construct or low in construct overall. Then this means a low internal consistency. So I hope this is clear with this picture. And when we talk about Cronbus alpha, again, the question behind this is that do a collection of items that we want to measure the construct with, measure the same characteristic. And it's the alpha quantifies the level of agreement among these items belonging to a construct between 0 and 1 scale. So it's a standardized measure. And higher values indicate higher agreement between items. So this is, you can see the formula here. You have number of items. So this is kind of a criticism in general about alpha, that if you increase the number of items, alpha will always increase. But it's also related to variance and covariance between the items. A high alpha, but we will not do a hand calculation of alpha in the course. You will just use one function in R. A high alpha, high alpha means that the covariance is high relative to the item variance because the variance is on the denominator. And it means that the relationship between the questions account for most of the overall variability. So meaning that we actually have high internal consistency. An important thing with calculation of alpha is that we need to reverse code items if needed before the reliability analysis. So if you have a negative formulation, remember from the last lecture, if you have a multi-scale item and then you have positively asked questions and one negatively asked question, then you need to reverse code that negatively asked questions, the scores that you get out of that. So then how do we conclude a high alpha? There is no formal test related to that, but once you calculate the alpha, the rule of thumb is this, basically. We want it to be around 0.8, 0.9, or like above 0.7 in general, but we also don't want it to be very high, so that's between 0.9 and 1. Because this too high means that probably people didn't get the difference between the items. So you're probably measuring the exact same thing. It is, yeah, in that case, it means that either your items are not working very well, or you can actually use a single item to measure the, to measure the underlying construct. So if basically people always give the same answers, you're asking the same question, and then these questions are not different enough for you to establish reliable measure. Good, let me check the time. Yeah, so we will talk about this in factor analysis possibly. So let's see. Wait, I need to. I think we are, we are over time indeed. So I think I will go factor analysis tomorrow. I will go over it. I will do a short introduction related to that tomorrow. But the factor analysis is basically a means to get from a lot of items to underlying constructs. So we will look at that tomorrow. I will just have I think 3 or 4 slides related to that, and then you will mainly learn it in the tutorial. Good. Are there any questions? I'm checking. So please, I mean, you can leave if you want to. Let me check the questions. So Nastya, do we need to calculate alpha using this formula? We will not ask you to do hand calculations, but it's good to understand, for instance, that alpha actually increases with the number of items. Okay, so you need to know how to read the formula, but you will not make calculations with the formula. And in the exam, you will provide it with the formula. So there will be a kind of a cheat sheet related to formulas. The quiz, the quiz can be in any of the lectures and any time. It could be tomorrow, it could be also next week's. So I can't say anything about that. The course related when is the latest you can submit the honesty declaration. The honesty declaration you need to submit once, and we want it to be before assignment 1 because that's when you actually like basically tomorrow then, because then you start to get grades, but those grades are only provisional if you didn't sign the honesty declaration. So please make sure that you sign it tomorrow. So the Cronbus alpha only works when different items have the same measurement. I'm not sure if this, I got this fully, but the Cronbus alpha only works if you have a multi-item scale, if that is what you're trying to ask. So if you have a single item, then we cannot talk about consistency of the items, right? Consistency of the questions, the answers to the question. So in that sense, only with multi-item scales, we can come up with Cronbus alpha. And if the response to the items are quite consistent, so if they are either within respondents, right? If we get high for for an environmentalist respondent, for instance, if we get high for each of the answers, then we can say that, okay, this is internally stable, internally consistent. But if the answers are everywhere, then we cannot talk about the consistency. And for that, we need multiple questions. Redoing quizzes. No, there are no makeups for the quizzes or assignments. You can redo, like if you mean you can upload, I don't think you cannot upload the assignments for sure. And also not the quizzes, but we will provide you with the answers to both, and you can just like basically answer the questions on your own and check the answers if you want to practice again. Will we get a cheat sheet for the exam? Yes, you will get a cheat sheet if it's needed. I mean, so for instance, if there's a question related to Cronbus alpha and we are testing, as I said, I mean, let's say one of the options is that Cronbus alpha increases with the number of items, then you need the formula to remember that. Then there will be a cheat sheet. Also for the R codes. So there will be R questions. The exam is closed book, but we will always provide you with all the codes that you can use. But you will need to know which code to use. Does that make sense? So you will get a list of codes, but we will not really say which code should you use for the particular question, for instance. You will get an example exam, so I think it will be clearer. Yeah, I understand. So unfortunately, like either you carry the grades or you do it this year. So there's no mix and match. The assignment 2 will be available tomorrow after the deadline of assignment 1. Because it also includes the questions, it also includes questions related to tomorrow's lecture. For quizzes, yeah, as I said, I think this is again related to the makeup. What you can do is you can you can choose to not carry quizzes, and then you can take the quizzes. But you cannot, like, once you take the quizzes this year, you cannot mix match with the last year's quizzes. That's my point. For the code grade, is there a way to do you, yeah, I'm not sure if, yeah, this is a very particular problem. It's very hard to know what the problem